So UR2 minus UR1, which is potential difference between the 2 points A and B, is a measure of the total work done in moving the object from a distance R1 to a distance R2. Is integral R1 to R2 G MEM over R squared dr. Okay, can you integrate this? If you notice, G, MEM, they are all constants. And so you need only integrate 1 over R squared dr. Do you know the integral of 1 over R squared dr? The integral of 1 over R squared dr is negative 1 over R. So this integrated will become negative G MEM, that's a constant. And integral of 1 over R squared dr is negative 1 over R. So this quantity integrated gives me negative G MEM over R, and the limits from R1 to R2. And that is a measure of the potential difference. The potential at B minus the potential at A is the potential difference between the 2 points. Well, if you now put in the upper limit and the lower limit, you put in the upper limit, this R becomes R2, negative G MEM over R2. Now you know how to do that. Minus negative will become positive G MEM over R1. So the right side is now this. Okay, now we're going to talk about, if we consider this R2, if this R2 or the point B is at infinity, if point B is infinite distance from the Earth, what will be the potential at point B? What did we say the potential at infinity is? 0. So if we consider R2 to be infinite, the first term on the right will become 0. The potential at infinite distance from the Earth is 0. Also, when R2 become infinity, any quantity divided by infinity will be 0. So the moment we say R2 is infinite distance from the Earth, it reduces this term to 0 and this term to 0, and that gives us negative UR1 is G MEM over R1. Now what does UR1 represent? Potential of the object at point A. In other words, this is a measure of the potential energy of an object of mass m placed at a distance r1. And now, if you rewrite this, potential energy at any point on this, in the surface of, in the gravitational field of the Earth, can now be written as, look at this, I replaced this R1 by any value R, and the negative I gave it to the right. So this is a measure of the potential energy of an object M placed at a distance R from the center of the Earth. It is UR is negative G MEM over R. A very important concept. And on the surface of the Earth, if you now want to find the potential energy on the surface of the Earth, this small r will become the radius of the Earth. Is that right? Therefore, the potential energy of a mass m on the surface of the Earth is U surface is negative G MEM over RE. So, look at this again. The potential energy of an object of mass m at a distance r from the center of the Earth is UR is negative G MEM over R. where this r can be replaced by re plus h, radius of the earth plus the altitude. And the potential energy on the surface of the earth is U surface is negative G MEM over RE. Again, very important concept. So potential energy on the surface of the earth is given by this quantity. And you know that GME be replaced by GRE squared. And therefore, U surface can now be written as negative GRE squared. The GRE squared is the replacement of big GME. And now, this RE and one RE from the numerator cancels. That giving us negative small g REM. This is a very good equation. The potential energy of an object placed on the surface of the earth. And now, potential energy of a mass m at an altitude h will be negative g MEM over RE plus h. So don't mix up these two equations. And that will be negative, this GME can be replaced by GRE squared. So that will be negative GRE squared m over RE plus h. This is the potential energy of an object of mass m at an altitude h. This is the potential energy of an object of mass m on the surface of the earth. Let's now talk about escape velocity. We are now in a position to talk about it. Escape velocity. Escape velocity is the velocity that you need to give to an object so that the object escapes the potential well. Alright, let's figure it out. Escape velocity, V escape, is the minimum velocity of projection so that the object will escape the Earth's gravitational field entirely. In other words, its potential energy will become zero. That's the meaning there. Since we have chosen potential energy at infinity to be zero, the potential energy of an object of mass m on the surface of the earth we know is this. This is the potential energy of an object on the surface of the earth. The potential energy of the same object at infinity will be zero. Suppose V escape is the velocity of projection. If you project an object with that velocity so that the object escapes the Earth's gravitational field, then this velocity V escape is just enough to take the object out of the potential well. So you give the object that velocity, the object just comes out of the well and collapses. That means its velocity will be reduced to zero. This velocity is just enough for it to escape the potential well. Okay, we will now use the conservation of energy to obtain an equation for the V escape. What is the conservation of energy? The total potential energy and kinetic energy on the surface of the earth must be equal to the total potential energy and kinetic energy at infinity. Alright, so U surface plus K surface equal to U infinity plus K infinity. The sum of the potential and kinetic energies of an object on the surface of the earth must be equal to the sum of the potential and kinetic energies of the object at infinity. Well, we have all these values. On the surface of the earth, the potential energy of the object is negative G REM. And if you throw the object with a velocity V escape, its kinetic energy, the moment you project it, will be 1/2 m V escape squared. When the object reaches infinite distance from the earth, its potential energy will be zero. its kinetic energy also will be 0, because the velocity is just enough for it to reach infinity. That means its total energy on the surface of the Earth will be negative GREM plus 1/2 mv escape squared. This is the total energy on the surface of the Earth. And total energy at infinity equal to 0. So we will now take this quantity and set it equal to 0 and solve for V escape. A neat way to get an equation for the escape velocity. So we have negative GREM plus 1/2 mv escape squared equal to 0. And that means multiply by 2 and divide by m. M will cancel. Multiply by 2, negative 2 GRE plus V escape squared equal to 0. Or V escape squared equal to 2 GRE. Or V escape is square root of 2 GRE. Well, we will now use these equations and all the concepts we developed so far in solving problems. Alright, I'm going to do that as a second part. So I'm going to stop this part here and I will solve problems for you using these concepts. Also, we will discuss Kepler's planetary laws in the second part. Alright, I'll see you for that in a little while.